2.4 seconds.
What is that?
2.4 seconds between full MSs. Okay.
That's right. So it's actually 0.4 per.
Which makes sense because it's about, you got 874 milliseconds of acquire time. You got 500 milliseconds of inject. Yeah, plus overhead. Are you waiting?
Yeah, our goal in life is to dig as much as possible. Trying to get the scan rate higher, the better. So maybe.
Do we use the full MS for anything, or just finding masses?
In the charge state determination.
So we don't, but you don't do any extraction of it ever. You're not doing peak areas or anything.
No, we do peak areas. If it's a detectable peak above the noise, then yeah.
Okay.
We are, in theory, wanting to be able to compare peak areas around the
If you want to do peak areas, so you want the number of full MSs possible.
Yeah.
Then what you want to do is you want to do an experiment where you do, instead of the big 5, do the big 3. Okay? And measure, just do the same exact measurement I just did, and see if the distance changes between your full MSs. If the distance remains the same, then the time is being limited by time to fill the trap, send to the FT, and do your detection. If the distance shortens, then the FT is actually waiting for the MSMSs to finish. Does that make sense? So we want the number of MSMSs to be as high as possible without making the FT wait to do the next experiment. You guys got that? So that's one thing to check is do a big 3 on the same data and see if the distance between the full MS change, you know you're being limited by the number of MSMSs, and just shorten it. Okay? You won't get more MS.
It'll give you better peak shape on it.
It'll give you better, right? It'll give you better peak shape on the full MS when you do your extractions.
Yeah, that's what because we originally had done the top. We tried lots of stuff and just counted the number of phosphorylation sites we found. So we did top 10, top 20, top 5.
Yeah.
And
on the LTQ,
it didn't really matter. Top 5 gave about the same number of phosphorylation sites, and you get better definition of the peak shapes.
Yeah. We usually find with the FT it's the big 3. On the LTQ it's the big 10. Just the LTQ alone without the FT is big 10. We usually find big 3 on the FT.
So it's a top 3 data, and that's what you mean.
Yeah. Yeah. Okay, now the last thing we want to check is if your monoisotopic is working properly.
Yeah, that probably isn't because I didn't add that. This one, I don't know.
So let's go.
Yeah, and isn't there something with the extract MSN that sometimes it gets the mono, and if it can't detect it, it uses less significant digits or something?
I give up trying to ask them what the exact deal with that algorithm is, but they keep changing it from version to version to version. Okay, so we've got a +2. You guys know you can turn on. How do I do that? Yeah, z equals 2. Do you know that one?
Cool.
Turn on the chart sheet, z equals 2. Okay.
So this is the McLafferty.
A Verigene. Yep, you got it.
So they just basically gave that away without you didn't have to license it.
Well, we didn't do anything with Thrash. We didn't want to get involved with Thrash because it's unclear who exactly owns what rights. So we just since we had Senko, we just rewrote the algorithm. Okay, so because Thrash is a nightmare trying to figure out who.
Because Dave was the one who wrote it. Dave Warren, he's at Agilent, but he was in that group for 3 years.
Most people think him and Agilent have a piece of the pie in there. Okay, but a lot of people also think that it's just McLafferty. Yeah, but I guess he made some changes to it over the years.
Yeah, maybe he refined it when he came to San Diego.
Yeah. So it's easier just to rewrite it and not have any links to the code. Okay, so we want to be at 581.77417.
So you also have the suggestion to try lower resolutions to see if maybe you can get better dynamic range. Is that the idea?
Better scan speed. Better scan speed, so you might be able to do more
That would actually
MSMSs.
reduce your dynamic range.
Dynamic range shouldn't be affected at all. I would think it would increase it because you would have more time to dig down into the dirt. So I would think it would increase dynamic range. Okay. So now the question is, where's our MS2? 1.77. We should be able to view his scan header. See right there? Monostopic M over Z. So it read it as 7746. That's not too bad. It's off by, and that just depends upon how we have slightly different code in Qual Browser than we do with the Verigine. Because there's different, Qual Browser is written in San Jose, and they're like, we're not doing the Verigine. So you're only off by.
So Verigine is the thing that's built into the FTP instrument.
Right. So this monostopic M over Z is coming into the raw file from the FT instrument control.
So this is a Verigine generated, right?
Right. Okay.
But you just said something about Qual Browser.
So Qual Browser, see how Qual Browser gives me a different number? When I clicked on the actual spectra, see, it gave me 77417, not 7746. Okay. So Qual Browser is just taking the centroid of the actual data point. It's not using the monoisotopic M over Z field.
What is that fishing about?
So what Extract MSN does, well, that's what I want to see is which version of Extract MSN you have. Because the correct one should go after the monoisotopic value, okay, and use that. If you have the wrong one, then what it's going to do is it's going to use this number right here from the scan header. Okay, so what we want to do is I want to look at your MSMS data that Sequest is producing. You're still using DTAs, not SRFs, right?
Yeah, you can't cluster this.
Okay, you can't cluster. So you want to look at your DTA and see, does it say 0.77 or does it say 7746?
Sometimes it does and sometimes it doesn't. At least at one point that I checked it.
Okay.
It's like a mixture. Look at it like that.
It'd be interesting to look at because if it's not putting it in there, it'd be interesting to look at the scan header and see, could a Verigine not produce it properly, or did BioWorks not grab it properly? Let me get out of your way. I'll be right back in a second. Are you guys understanding this? Because you're sitting there real quiet. Okay, if this is good, I will go nuts all week if this is a conversation between me and Art. Okay.
I like that.
You guys can jump right in. You have incredibly powerful stuff to add to our conversation.
say